Good morning, good afternoon, good afternoon, everyone, or good evening. My name is Ron Dagdag, and today I will be talking about managing IoT devices in Azure, and we're going to talk about the simpler way of doing it. So this is a picture of my daughter, and that day I had a great time. There was a Lego convention here in town, and we attended it. And there's a bunch of Legos, and that she loves Legos and learning all those different Legos. And of course, if you're a parent, most likely you stepped on one of these Legos out in the living room and all that. But so I gave her a challenge that day and said, "Can you build me a house?" Because there's a bunch of Lego pieces right there, and yeah, she did this one, and I think it's pretty nice. I mean, it does look like a house. It does not have walls, but there's a small kitchen over there, and I think it's cute. Uh, and then of course, few years later, we I bought her one of these Lego pieces or Lego kit. I guess this one is Mega Block, and the same approach, right? You build me a house from these pieces, and if you compare these versus that one, I mean that one is a much better toy house or doll house as compared to the previous one. Uh, but it's simpler for someone that's beginning and trying to understand. So that's my point here in terms of having a guide of what would make it simpler to do in order to accomplish some task. And today our agenda, we're going to talk about what is Internet of Things, and then IoT Central, which is part of Azure. I'm going to focus on that one and what makes it simpler as compared to the other things that are available in Azure to do on Internet of Things. What is the benefit of it? Uh, we're going to talk about what is a device template, IoT plug and play, how do you visualize data that you're receiving from IoT devices, and integration with other Azure uh, services. Let's get started. Um, if you have questions, feel free to uh, unmute or raise your hand. Um, this is a small group. I can answer them as needed, and also it helps everyone in the team to to understand more if you need details. So, what is IoT? IoT, the way I kind of look at it, is there's things. You have things. This is a thing, right? That you send data from this thing to the cloud, and then you do some transformation of that data uh, to improve your business. So it's Internet of Things is a network of connected devices and objects, allows you to send and receive data over the internet. Typically, it's connected to the internet or other device systems. An IoT device will have some sensors that can detect, maybe various ambient condition, temperature, or other things, all these other sensors, and then data is collected that is used for either live monitoring or some analysis. At the end of the day, it's business decision making. There are two goals whenever you're working on Internet of Things device, right? One is remotely monitor your your devices, right? This is where you're gathering data or you doing some minimal device processing, knowing that status of that device, how is it performing, and then also controlling that device. This is when you're trying to send commands to that device or some device properties. So typically when you want to start learning about Internet of Things that's out there, a lot of resources are available. A lot of, if you've heard of Raspberry Pis or Arduinos, that's typically the ones that people start with. learning more. Of course, the difference between the two is that Raspberry Pi has it's a microprocessor. It has an operating system, and it's using Linux, or you can actually install Ubuntu or running on that machine. And then, of course, Arduino is a microcontroller. It's using, you know, RTOS, a real-time operating system. It does not have the usual Linux operating system that we're used to, and they both have different ways in how you would program them. And of course, whenever you install these IoT systems, like let's say in a factory or in a retail store or different different uh, in different areas, right? Or weather stations and all these, there there's issues that you'll see in the field in scaling these devices, right? And so these are different attributes of what a successful Internet of Things solutions are. One is, of course, whenever you're talking about this, you have to think about scaling these, scaling not just storage, but you also have to scale compute, networking, and you may have multi-tenancy around your system that you have to consider. Another one is device management. There's a life cycle on one of these devices. It could be you have to figure out, how do you provision them? How do you connect them to the internet, the Wi-Fi credentials and those kind of things? Or even if they're not using Wi-Fi, how do you update the software on these devices? Another way is big data management. So there's the data that you're collecting from these devices, and you have to consider them. Do you need to store them in a hot path? And you'll hear this a lot more: hot path, warm path, or cold path. It's how you store these data that you collected and how fast you can access it after it writes it to on disk. And so there's different modes on how you would manage that data. And then once you start having analytics, insights, and extensibility, you also have to think about some of the different rules, right? And some automated actions and some integrations to your alerting system. So think about, if one of the devices are off and it's not working, or it's having some issue or calibration issues, you want to know that, and managing that and identifying those actions would require you to consider and plan. Another one is high availability and disaster recovery. Some devices out there, especially IoT devices that are deployed in a hospital, or some mission critical uh, location, these devices have to have high availability and disaster recovery. They have to be resilient to failures on the network or even disk, right? Um, and then security and compliance, because these devices are deployed somewhere that may be remote, that there's not a lot of people. If you think about uh, oil uh, oil fields, where they're constantly monitoring the well. So security, we got to make sure that, and also compliance as it transfer data from that device to the cloud. So think about connectivity, integrating your data, and data protection. Those are the considerations. And managing IoT solutions with DevOps, when you're building or managing and provisioning and deploying code. The more we can automate some of these with the DevOps in mind, the better we are in building a proper IoT solution. And then, of course, after all that, you make sure it's within the budget, right? Understanding the cost and the total cost of ownership of not just the device itself, but storing that data and transferring that data to the cloud. All right, and then there's a lot to consider when you're creating an Internet of Things application. Uh, And then, of course, we all live, especially in Azure, we all live in this as developers in the IT, right? The information technology. We talk about the cloud, the software as a service. We typically, whenever we talk about IT, it's asset management and HTTP, all these different things, and of course, there's the world out there of operational technology. If you're not familiar with that, it's been that a lot of these old devices out there, or not just old devices, a lot of machineries out there, they do have program running in them, right? They have these controllers and PLC devices, and they have sensors, uh, especially in an assembly line or a machinery, that someone is responsible of keeping track and making sure that is operational, right? That everything's doing great in the factory, or doing the sensors are working great, and all the things involved in that. So I did talk about IT and OT, right? And the difference. And then there's, of course, the one in between. Now, as we build Internet of Things devices, we're talking about the combination of IT and OT. And this is the world of IoT, right? And the user roles in IoT, things you have to consider whenever a successful deployment. One is the administrator. They're the ones responsible for administrative tasks, assigning different roles and permission to our users. And then there's the role of a device developer. They're the ones who would program some of these devices, right? For some of these IoT devices. And then the operator, we did talk about OT, right? They're the ones that are managing these devices as you deploy them, as it so that it can connect to our IoT cloud application. And of course, us and Azure developers, we're the solution builder, and we're the ones that builds IoT cloud solution that these device can connect to. Uh, so those are the so today I'm going to focus on the role of a solution builder and how we can uh, how it's being used in Azure. So what is IoT Central? Um, it's a way for connecting and monitoring and managing IoT assets at scale. The keyword here is at scale, and being able to easily scale your IoT application through, of course, quick connectivity, already pre-built libraries that you can and samples out there, centralized management, so a place where you can look at all the devices that are connected, and then visualization. It allows you to have these reports and charts for analysis, and it is a bridge between applications and IoT data. Do we have any questions so far in the chat or anything?
We're keeping an eye on the chat, Ron, and it looks like nobody has questions thus far.
Okay, I will continue. So I did talk about things, right? And then the cloud, and then the transformation. So devices, you have all these devices that you can connect, and IoT Central manages devices and acquiring and connecting and securing it to the cloud. So IoT Central can do this right now. As a solution builder, this is our side, which is the transformation of these data and using what data that we can collect through these devices and bring business value from there. So what are the benefits? There's low code environment, and I did talk a little bit about data analysis, and later on I will demo what that looks like. It's good at dealing with non-frequently changing data, and It also has ready-to-use templates to start with, depending on the use case that you're building. Uh, there might be already a pre-built template available for that. And then it does support different types of device measurement. So in terms of the unit of measure, they have that. And then it's highly secured and authorization and authentication. And we'll do a demo on this one and how to log in and all that. So how you would leverage, of course, collecting information and then monitoring the devices, and then you're analyzing what the data that you collected and then deciding what you want to do with that data. So those are the 4 steps. So I did talk about Legos, and I'm gonna connect, what Lego means to my presentation. We are familiar with infrastructure as a service, and you most likely you've heard also about platform as a service, which is infrastructure focused software development service. Uh, and then there's a lot of SaaS or software application as a service that's out there. Think about Office 365, that's a software application service. Uh, of course, IaaS is more of like VMs in the cloud or Kubernetes, and those are more infrastructure as a service. But there is one that's called APaaS, Application Platform as a Service. So it is closer to SaaS, but you can customize it more. But it is considered as software development focused, software development services. So in terms of the Lego itself, right? Because IT Central has like ready-to-use templates, has instructions on how you would do this. IT Central is considered an APaaS or application platform as a service. So because IT Central is application platform as service, it's actually a collection of a bunch of Azure services that is out there. So not just from the IoT Hub, it's actually using IoT Hub in the in the background, right? Also using DPS or device provisioning service. It's also, as it receives data, it uses Azure Stream Analytics. It's using Data Explorer for warm path. It's using SQL DB for cold path. So it has all these different services that it's using, and of course, it can on the right side on the business integration, it can export data, trigger alerts, or query data uh, through the management web experience. It's so on the device side, on this side right here, it's using Azure IoT SDK or Azure RTOS. So depending on the devices that you're using, and then also Azure Sphere or Azure IoT Edge. So there's different ways on how you would connect to the cloud. So when should you use IoT Central? When should we use this service? If your team does lack experience in building an IoT application, and we did talk about how complex building an IoT application is, consider using IoT Central because it's you look at the abilities of your team, like in my team where I work at, we have a lot of .NET developers and also JavaScript developers and Node developers. And so that is the common skill set that we have. And then we can use Azure IoT Central to help us customize that platform with the ready-to-use application. So instead of building from scratch, we can use IoT Central and start building companion apps that is custom built solution rather than custom built solution from scratch. So when should you not use Azure IoT Central? Maybe it might well worth using Azure IoT Hub as a better option for you. because in your team there's might be experienced professional that wants full control over the whole IoT solution. So it depends on what, of course, at the end of the day, right? It depends on what you're trying to do, and how much data are you needing uh, to process, or how much control you want over the IoT solution. So here's a question for you. Um, a lot of us, we've seen Windows, have used Windows most likely. What made Windows successful? It's a lot of places where Windows is installed. What made it successful is because they work with other device manufacturer to have compatible device. If you think about it, you plug something like a camera in your laptop, and instinctively know what device driver it's going to use in order to display it, right? In order to connect. And it's a bunch of different components that's working together. You may have a different hard drive, different monitor, and how they work together to build the whole system. The same way as Alexa devices. If you I treat Alexa as my home operating system, because you have all these smart homes, right? You have all these different lighting manufacturers, different plugs. You have voice assistants, different TV, and how seamlessly you can create rules to talk to each other, and you can create an Alexa skill set. Because I used to do that, and being able to control some of these IoT devices, or these smart home devices. So Azure has this Azure IoT plug and play that integrates smart device solution. The device itself advertises its capabilities to IoT Central to reduce the hassle of configuring, as creating templates and features and all the different things and how you would communicate to this device. There is an Azure device catalog that you can look at what are available devices out there that you can plug into IoT Central. So I have one right here, which is an ESP32 IoT kit, and this one right on this screen. So you can connect that. And it simplifies that process. And of course, there's other devices that are available too. So there's three different device types in IoT Central. One is an IoT device, an IoT edge device, and gateway devices. Let's look at each one of them. IoT device is a freestanding device. This is a freestanding device. It connects to uh, the internet, and then it can send telemetry data, and it can report values, and it can receive property values and response to command. Another one is an IoT edge device. This acts as a standalone device or a middleman to if another device can't connect to the cloud. So it has the ability to process data locally. So if you think about this, it could be a Raspberry Pi that has Docker containers running in it. And so it can process those Docker containers and then connect to the cloud. So that's how it runs an IoT edge device. Another one is a gateway device. A gateway device is the one that manages other devices that connects to IoT Central. So, there are some low power device out there, let's say, that is using, let's say, you know, a, a different protocol instead of directly connecting to Wi-Fi, right? So a gateway device is like uh, where some of these IoT device would connect to and can talk, let's say, LoRa, or can talk some other protocol, and then forwards that message, then that connects to IoT Central.
I had a question, Ron.
Yes, sir.
Yeah,
Hey,
you,
Bill.
you might have just answered it, I was thinking of the question when you were on the IoT edge device
Mhm.
section. You talked about that being potentially a middleman for other devices that can't connect directly to the cloud. In that, I guess you just explained that. I guess a gateway sounds similar to that too. In that,
Yes.
yeah, I have a sensor in my house that that collects the temperature and humidity and things like that, and it can't talk to the internet. It talks
Mhm.
to a gateway that
Right.
then can talk to the internet. It can have multiple sensors. Um, is that so? So I get the concept of a gateway in that context. Is there another context that I'm missing for where one edge device in the middle row could do work for another, or it could be its middleman?
So if you think about what is a good example of this? Is it there's service in Azure where you can run it uh, at the edge, meaning oh, I'm trying to find that word. So it can process some of the images from the camera in between. Uh, okay, it'll come back to me, but you can have these devices, this edge device that can do some processing before you send it to the cloud. And typically, you would run it in like a Kubernetes, or you would run that on a. There's an Azure IoT Edge that runs containers closer to containers in the same network as your IoT edge devices. So it can do
Uh,
the processing or pre-processing data locally instead of sending directly to the cloud.
I
So you
get it. I
can
think I
yeah,
actually learned this from Veronica. She talked about the cognitive services.
that's
They
correct.
they have containers that you can stick out on the
That's
edge,
correct.
and I
So
hadn't thought about those as doing work for other devices before sending it centrally. But that makes complete sense
yes.
now that you
So
explain it, Ron.
yes. So cognitive services can run. You can actually have SQL Edge running on there, right? So instead of the SQL server running in the cloud, you can have SQL Edge running on an IoT Edge device, and that your IoT Edge, your processing can happen there. That's a good question.
I appreciate the extra color, Ron. Thank you.
Yes. There's multiple ways in how you would connect to IoT Central. Of course, this is the same underlying structure as you would connect an IoT to IoT Hub. You can use either a shared access key signature. You can use X509 certificates or the trusted platform module. A lot of examples out there is using the shared access signature, which is kind of like a connection string. Uh, how it would connect to IoT Central. That's typically the easiest way. And then in terms of communication protocols, it's possible to send it through MQTT. It's using MQTT, AMQP, or HTTPS. So if depending on the network, if they block some of uh, these protocols, you have choices in how to send data to IoT Central. Device templates, think about it as a blueprint or definition of how to talk to the device. And typically there's three ways on how you would do this. The three components of a device template. One is what is what's telemetry that you'll be receiving. These are the device sends data to the cloud and sends telemetry data. Another one is sync properties, and these are typically we call them device twin, but it synchronizes, you know, between the cloud and the device. If device changes the some of the properties, eventually it would reflect that information to cloud, or vice versa, right? You change the number or the property in the cloud, it knows how to synchronize itself to the device that its goal is to make sure that they're all the same. And then another one is commands. These are cloud calls on device. So the difference between properties and commands, commands requires that the device is on so that you can send command to it. Properties, even though let's say the device is offline and maybe not connected to the internet, you can change the property, and then eventually it would synchronize the device once it it reboots itself, or once it's connected back to IoT Central. So let's look at IoT device, IoT Central device provisioning. How are we on time? Um, how long do we usually have our presentation? Is it an hour?
Another 90 minutes.
90 minutes. Okay.
No, not another 90 minutes, but what's the most natural amount of time that would make sense to wrap it up with?
Okay.
Like,
I want to make sure, because I can talk about this all day. I want to make sure I don't waste everyone's time. So
yeah,
let's do a demo of what IoT Central would look like. Okay. So if you go to apps at iotcentral.com, okay, you can actually build an app here. And it's either you can create your own custom app, or you can select in one of these if you just want to try it out. So these are the templates that they have. If you want to know more about retail, energy, government, healthcare. So there's some examples out there and some documentation around it to understand what data would you be receiving. So today we're just going to create our own custom app, and of course it will ask us for application name and then the URL .azure.iotcentral.com. You specify that it is a custom template, and then in terms of the pricing plan, each one of these have 2 free devices, and you have to select how many messages you receive from that device. And of course, it costs, I think, the pricing model, it's like maybe less than $1 per device per month in order to connect to this. There's different pricing models for each one of these, so it just depends on how many messages can you receive. So we're going to select standard 2, and then of course you need your Azure subscription in order to connect to it, and then just click create. So I created one already, since I want to make sure and this is what it looks like. So first set, you'll have the application, so you can do some customization a little bit on this, change, upload image and icons, those kind of things to make it a little bit nicer, right? And then on the application itself, you can do some management for this, and what you can change the application name and application ID, those kind of things. So we'll focus on the connection part of it. So let's go back to my other screen, to the presentation.
Ron, we have a question in the chat.
Okay.
If we have a gateway, the commands can be routed from cloud to gateway to the IoT device.
Yes, there's a way to do that. Because you can register your gateway to IoT Central, and each one of the devices, also IoT device, can route those messages to the gateway, and then the gateway to IoT Central, and vice versa.
Thank you.
So IoT Central, let's see, where's provisioning? I thought I have my other screen here. Okay. So on the provisioning side, I'm going to click create new device, and this new device, I specified sample device IoT. or sample device 01. I'm not going to assign a device template because I haven't built one. And then it would have these. It tells me the device name. It's just there's different device status right now. We just created this device, and it knows what organization it belongs to, which is you can have multi-tenancy and multi-organization on this. So think about organization is where you can have factory 1 versus factory 2. All devices on factory 1 belongs to one or sub-organization, and then factory 2 belongs to another sub-organization, however you want to. So you can manage these devices. And then, of course, the device template, we'll talk more on that. So once you have your device, it would tell you how you would connect to it. So it would have the scope on how you would connect, the device ID. You can, and then it'll give you the, in a way, connection string, the primary key and secondary key, if you use the shared access signature. So once you have that, I'll go back to, I have these sample code, and I'll give you a link on this one later on. In this sample code, this is just a C# application, and I want this one to act like an IoT device running on my laptop, just to simplify things. And it knows how, and it knows how to connect to IoT Central already because we specified some of the scope. And then I'm going to run this. Let's see, am I in the right folder? Temperature controller, .NET run. So I'm going to run this, and what this application does, it acts kind of like a, an IoT device, like one of those temperature monitoring device, to where you can, monitor the temperature, send it to the cloud, and then also control and change the thermostat. So think about the thermostat in your home, and it's sending the updates every few seconds, and it connects to IoT Central that way. Let's go back to the other screen we have here. I'm going to refresh this. Notice how it created this device template. So the sample device, the one running on my machine, it connected because it's using the SAS, the shared access key, and is able to connect, and it reported a new device template. And let me tell you what this device template looks like. This device template gives you information about the device itself. Remember, I did talk to you about plug and play. This is where Azure IoT plug and play does, is it reports, okay, this is how you're going to talk to me. So the device itself says, this is how IoT Central can talk to me. And it has all these different capabilities, all the different values on how you would, you have the serial number, the working set, and commands to reboot, some of the properties and all that. So let's look at this device, going back here, and this device right there. Since it knows how to, what is, based from the device template, it knows how to communicate. So it has these temperature values and what it's receiving from that device. Commands, if you want to reboot that temperature controller to get some of these values for get min and max report. And then also on IoT Central, you can see what are the data that you are receiving from the device to cloud, and it maps some of these values, thermostat 1/temperature, thermostat 2/temperature. So each one is actually just sending a JSON payload of what the current temperature is of each one of this thermostat, and then with the timestamp. So there's telemetry right there, and also this is when it wakes up. and the event type is device connected. Timestamp. So that then right there, it's provisioned. It woke up. It connected to the from my machine. It connected to the IoT Central instance, and it's communicating. Okay, let's go back to the presentation. So visualizing data, I think I have a slide that I have here. So monitoring, there's two types of monitoring, the health of your application, and then of course, the health of the IoT device. And of course, as you receive this data, there's historical data that you collected from your device. So device monitoring is identifying if there are issues with them, what's the status, device status. And then of course, the application monitoring, how is the application platform as a service, APaaS, right? How is IoT Central performing? There's, of course, in Azure, there's metrics that can provide chart. There's also a way you can, the REST APIs and on the Azure portal to know how IoT Central is performing. So let me show you what device monitoring looks like. So here's an example. You can actually build different dashboards on IoT Central, monitoring each one of the devices that you have in your, let's say, factory floor or the retail store. So there's ways you can create some of these graphs. So let's do that. Let's try to go back here and go to dashboards. I did talk about dashboard. You can make your own dashboard, or you can build one. And there's a way you can specify, okay, a chart data that you're receiving. I want to create a line chart, and on here, I guess it's complaining about, for some reason, the device template associated. So let's try to cancel that. Let's create a new one. So you can create new. And let's say I just want the personal dashboard, or you can do it per organization. So let's say the whole factory floor, or the whole organization can monitor some of these devices. So let's go with personal, and then I can edit this dashboard. I can create a line chart, and then I can edit this line chart, and let's say, okay, for all devices that are temperature controller, I want to specify this device and just give me a chart on that, which telemetry and which capability I want to monitor. I want to monitor the first thermostat, and click, and then see if we add again the other thermostat, and then click update. Notice how it builds me a line chart that I can monitor for this. So that's one way you can see as you receive this data, it's building a chart for you. Another one is through Data Explorer. Data Explorer you can create some queries, and if you just want to analyze what's going on with your devices, you can do it here. And then let's say look at historical values, and then visualize it from there. And this one is using Azure time series to visualize. So there's different options. All right, let's move forward.
Quick question, Ron.
Yes, sir.
On the data that the IoT Central is collecting, does it have a limit on how much data it's going to store? Do you get to tell it, I want to keep it forever? It'll only keep it for 3 months, anything like that?
Yes, there's a limit. I believe it's 90 days on what it would store, and then it falls off from there. That's why you have all these APIs and data export, which I'm going to talk about next, and how to get the data out for longer storage, right?
Makes sense. Thanks.
So they're all temporary, connected there. You can build reports, mostly status of what's going on with your device. So jobs. Jobs is the way you can manage connected devices at scale. You can do bulk updates because you think about, this is actually built for scale. Scale means thousands or thousands or, 100,000s or 200, a million devices. It can go up to a million devices that you could be managing out there. And you have to think about, okay, if I want to run command on these devices, how do I do them in bulk? Because I'm not going to do that for each one each one of these devices. You're going to run it in batch. So that's where you have jobs, and you can have all these different devices have it in CSV file to import and export, so you can do the batching. So let's do that. Let's try to visualize what jobs would look like. So if I go back to IoT Central, there is manage and there's jobs right here. And of course, you can schedule and create a job. And that's what I'm doing on the screen. So like in this case, configure a job, you specify it. Sorry about that. I have an alarm going on. Okay, I'm back. Wasn't expecting this alarm. Okay, so I configured a job. I specified, okay, what type of devices am I going to control or going to change? In this case, I want my temperature controller. I want to change the property, uh, you know, thermostat target temperature. I want to specify. So this one is changing properties, and I wanted to say, okay, now thermostat one, your target temperature has to be 25 degrees. So then that's how it's going to send it. And what it's going to do is it will look for all the devices under that device group, right? That works on that device template under that organization, and then start calling them, each one of these devices, and then changing the target temperature. And then once it's done, once it executes, there's, it would tell you how many failed, how many got completed, how many is in the process, how long did it take, and which one of the devices that it went through and update. So that's jobs, right? So the advantage of this one is there's different rules where you would batch them. So there's also cancellation threshold, or different uh, rules that says, hey, you have thousands of devices you're updating, and the first 10 failed. Should I continue with the 10, thousands of devices? So you can have this cancellation threshold that if 5 or 10 devices in the first run failed already, yeah, just cancel the whole job and don't run it, because we don't want to destroy some of the devices out there, especially if it's mission critical device. So those one way you can start batching them. All right, so that's jobs. Let's start extending, and what are the different ways and how you can extend IoT Central. So like I said, you can have a companion app in IoT Central so that you can start using some of these data that it's receiving when it's exporting the data, rules, and then REST API. Let's go through each one. Exporting, this is how you would integrate. So you can export it through, Event Hub, Service Bus, blob storage, some of this information. And let's go through each one. So on the data export, you can either go through Azure Event Hub, where you can, of course, if you're not familiar with, can process events with speed and precision. Service Bus, if you wanted to make sure they are in order, you can export data to Azure Service Bus. And then blob storage for unstructured data. So this is for long term. you can export data that you're receiving from IoT Central from device to IoT Central and then to blob storage. Another one is through data lake, where you can process large amount of data. The easiest way that especially if you have API, you can connect a webhook endpoint, and then you can, have rules against that, or rules defined for that. So here's a good example on how you would do this. In this case, I'm selecting webhook as part of destination. So how I got there to this page is I would go to data export. In this case, I'm going to go to destination. I'm going to create a new destination, and I'm going to specify webhook because that's the simplest way, but you can actually experiment to try different ones. And then you specify the callback URL, authentication, and some of the headers. And that's what I'm doing here. So in this case, there's no authorization. I'm just pushing it to that callback URL, and then that's it. And then on the data export side, so once you have a destination is a place where you can send the data. The export is where you specify what data are you going to send to that destination. So in here, I can have multiple destinations for the same data that I'm exporting from IoT Central. So in the screen where we specify, okay, the device that I'm going to do data export, it has to have the word sample in it. So I can filter, because I think about thousands or hundreds of thousands of devices, and I just want a certain location. So you can have filter or certain type of devices. You can do that. And then, of course, if I want to add a metadata, I can. So in this case, is sample, I specify is true. So anytime it exports data, it will have that metadata information, or what we call enrichments. And also you can export organization it belongs to. And then on the destination side, in this case, I'm specifying that it's going to go to my HTTP or my webhook. Notice how there's data transformation here. And the data transformation allows you to restructure the JSON payload as you're exporting data out of IoT Central to where it needs to be. You can rename the fields, filter out the fields. This would be good if you have existing application out there that already have some, process the data, or sometimes you just want some calculations or conversions before you store it to your. So this runs something in between your data the data transformation. So it looks something like this, right? Typically, on the data transformation, you would create these. This is using a JQ, which is kind of like a language for manipulating a JSON payload, and this one, you specify what the device template would look like, and then the output would look something like this, right? So let me go back to that screen, and maybe it'll make sense to show you. So typically, the data that you would receive from data export would look something like this, right? It's a JSON payload with all the properties that is reported on that, on all organization for that. And what it's the build transformation query would look at this JSON payload and convert it or transform it to look something like this. So it kind of flattens, and it kind of simplify what data would get stored. So let's say if you're going to send this to blob storage, it's better to parse this later on than all these massive ones. So that's what it's for. So it has that customization piece that you can do to enrich or transform your data. Okay, any questions so far? I know I'm going through it fast, and if you really want to delve deeper on this topic, there's a lot of tutorials out there, especially on Microsoft Learn, to understand more about this. And there's also on GitHub, there's some tutorials.
Hey Ron,
Yeah,
I got a small question. I apologize because my laptop rebooted. I just started with the presentation, so you might have already talked
Okay.
about this. But
All right.
I'm kind of curious. So let's just assume you have that factory. You got all those IoT devices spread out all over your factory.
Mhm.
Those devices are actually making the call into IoT Central directly into Azure.
That's one type of device, right?
Okay.
That's an IoT device that is connected. So if, let's say, your IoT device has a Wi-Fi connection directly to Azure
Yep.
IoT Central, then it can start sending that. If it, there's use cases where the device does not have a direct internet connection, but in order to send to IoT Central, you need Wi-Fi, you need internet connection. So in that case, that use case, you need a gateway device that would
Okay,
run
so
in
that'd be like
between.
a scenario of like an Arduino or something where you might be just getting some sense data, like temperature data, but it doesn't know enough about Wi-Fi. That's the gateway scenario, right?
Right, right. So
Okay.
a Raspberry Pi can act as a gateway, right?
Okay. So, like, given those scenarios, how do you let's go with the simple one. If you have the Raspberry Pi, how do you authorize the request from the device into IoT Central? So we'll just keep a simple case. I mean, what gives it the access to it? Did you generate a SAS key or
Yes, yes, it does. So it's like a connection string, and each
okay.
device have their own connection string. So that's what makes it more secure, right? So
Okay.
since each device have their own connection string, you can just delete that device or block that device from connecting to IT Central, and then if, let's say, that device gets compromised, none of your other systems are compromised because
Yeah,
of
you can
that.
revoke it. Okay.
Yeah, and you
Okay,
can
got it.
revoke. Yes.
Awesome. Thank you.
Yeah, no problem. So rules is where you can notify operators in other systems, right? This is more of the business process flows and alerts on the custom dashboards. So it would look something like this. Let's go back to that screen where I was. So this is on IoT Central. You can have rules, and then on these rules, I can create a rule. Okay. And then I'll go back to the presentation. So this rule, in this case, I want to say if the temperature hits a certain number of degrees in 5 minute span, let me know, because it might be something important. So in this case, I'm looking at these devices that have the serial number that starts with SR. So a property of that device. So if I go back to this device right here, each one of the device can report its properties. So if I click about, see how it says serial number. So these are properties. We did talk about a little bit about properties. And then this one's also is another property where you can, like a device twin. So this is the one we're talking about here. If the serial number starts with SR, use that device as part of this rule. You can also have multiple filters against that. And then on the condition, it says you do a time aggregation every 5 minutes if the temperature of a certain, maximum, in this case, 35 degrees, then you can call a webhook. You can do Azure function, logic apps, however you need to, or you can have other actions too. You can send an email. You can, Azure Monitor action groups. You can send it to Power Automate or a Logic app to do this. So you can have all these different rules that trigger something else in Azure, so that you can get alerted or a workflow that needs to happen. So you can send email. Maybe you can call, as SMS or text message. You can do voice or webhook. So just different options as you can do to uh, to send messages. Okay, moving to REST API. REST API allows us to do app management, device modeling, device onboarding. I did talk about it's the difference between app management and device management and data insights. App management, so if you want to there's you want to create rules, or if you want to there's a REST API to create some of the options that is on here. If you want to create a job, there's an API to create the job without going through these screens. Device modeling, you can upload a device template. Device onboarding, it's more provisioning a device, creating the SaaS key, right, or the the connection string. And then the device management, of course, managing that device, making sure that changing the properties on that device and all that. And then the data insight. Today, I'm going to focus on device management, and I'll show you how that flows. So before you can call the API, IoT Central API, you have to have a token, and then you have to specify the role of that token. Like in this case, I named it test token, and it's an app operator role, and it would generate the token for you. It will only generate it once. So you have to store that key, the API key, to be able to call. And then in this case, I can send a patch request. And this patch request, it tells connect to your IoT Central /API. You specify the name of that device or the device key, and then I'm changing the property of that device. And then, of course, there's different API versions so that you can identify which API that which version that you're using. And then in this case, I'm changing the target temperature, which is the target temperature. If I go here, I'm changing this. I mean, I can change it manually, right? I can change this. This is the desired, what I want it to be, and this is what the device is reporting right now. So let's try to do that in an API. And then, of course, once you run it, it would give you a 202. So let's do that. So I have the same one right here. So this is a patch call to my API. I have to send the authorization, the shared access signature, which is my API token, and then call these. And then I'm going to send that request. So once I send that request, I would receive a callback, right? We're calling that patch request, and it would give me if it was successful or not, and it would give me this payload and change it to the desired temperature to 20. So notice how this is my, the device that I provisioned a while ago, and it received that message already since it's connected to the internet. And on here, notice how this one changed. It was 0 a while ago. Now the target temperature is 20. And then if I go to overview, it start changing the temperature to reach 20. It was 22 and now it's going down. So that's what it's doing right now. So we changed the property, and of course it did something to change, and this is the current temperature that it's reporting. Okay, so there's REST API calls that you can so think about it. You have a companion app, not necessarily their users doesn't have to log into IoT Central in order to do this. The companion app can be responsible to managing some of these IoT devices. Wait, there's more. Of course, if you're into industrial IoT, we did talk a little bit about gateways, because especially on some of the OT devices out there, if you have a PLC, some existing machinery that has controllers, and there's ways that you can connect it to a gateway, which that gateway connects to IoT Central, and then you can do your processing after that. Okay, in summary, Internet of Things, two goals. Either you're remotely monitoring or controlling the device. IoT Central. What is IoT Central? It simplifies the creation of IoT solutions. What are the benefits? A lot of it is low code environment. There's a lot of flexibility on how you can customize it and able to manage an IoT Central application. There's device template, where we talked about what is a difference between telemetry, properties, and commands. And then I talk about IoT plug and play, which is a device catalog. That device itself that you're using reports how it can talk to from IoT, how IoT Central can talk to that device. I did a quick demo on what the dashboards would look like, some integration between the rules, data export, and API. If you're interested in getting the demo that I did today, or that application, you can take a picture of this, or get the GitHub link, and I can paste that on the chat later on. And I'm open to questions if you have. I know there's a lot of things that I did and I went through really fast, but my goal here is not to overwhelm you. My goal here is to kind of show you, like, hey, these are possibilities on how you would use IoT Central, and if in case there's a use case or not something that that there's a need for you're already familiar with some of the things it can do. If you want to learn more, there's call to action. On Microsoft Learn, you can learn more about IoT Central. There's documentation for the REST API. Also, there's some resources on GitHub about IoT Central and how to manage applications using the REST API. With that, if you're interested in learning more about me, I'm Ron Dagdag, Director of Software Engineering at Spacee. I'm a 6-year Microsoft MVP awardee. The best way to contact me is through Twitter and LinkedIn, at Ron Dagdag, or on LinkedIn, Ron Dagdag. I appreciate any feedback. I want to improve my skill presenting. And also, if you learn something new, or at some point in time, that's why I wanted us to connect through LinkedIn. At some point in time, if there's anything that one of the presentations I did, or I did talk about, something that you're able to use sometime in the future, I appreciate hearing back from you, because it validates the stuff that I'm doing. The reason why I'm doing this is because I know, as a developer, there's a lot of technologies out there, and sometimes a little bit of introduction or a little bit of something goes a long way in understanding all the different technologies. And so I appreciate your time. Feel free if you have any questions. This would be the best time.
Yeah, I'll just echo Ron's point. If you have questions, feel free to come off mute and pose the question. I do have one question for you, Ron. If in your demo, you gave an example of using, would it be called a digital twin, or what was like the
properties?
Is that okay?
Device
so
properties.
we used basically a fake device, right? That
Yes.
didn't exist in the real world to have a conversation with it, and it sent you temperature updates and such. I'm curious if you have any advice for somebody who wants to get started with a physical IoT device. I know you showed in the marketplace earlier the I guess I don't know, certified devices or something. It was a special list. Yeah, what would you start with if you looking to just kick the tires on this, didn't want to spend a ton of money, but wanted to do something in the real world?
I mean, the easiest, well, not the easiest way. I mean, we're application developers. If you have, you can run this, .NET runs on a Raspberry Pi, and you can build this, your device through Raspberry Pi. There's also, JavaScript, there's a way you can connect node application and read sensor data. That, for me, that's the simplest way. Since we're, in our world, we're already familiar with some of these languages that is available out there, and it's cheap enough if you wanted to introduce, if there's already existing applications or sensors out there that is available. So like this one, they have a tutorial on how you would do this, and step by step. It got a little bit of complex, I tell you why, because there's different kinds of programmers, right? There's developers that actually, their world is not in Azure. In Azure, we live in the world of gigabytes and megabytes, right? And there are some developers that live in the kilobyte world, that the memory on, the usage, and so there's a different construct and how you would do programming on it. And so, for us, the as developers, we can use Python, JavaScript, Go, and have these. And that's what one of the demos I have here is just this is just a, a C# application that connects to the cloud. And we can start from there, and then you can go in and understand more of the microcontrollers. And if you really want to really run it on a devices that are constrained, right? The memory constraint and low power. So it just depends on how, the battery life, how you're going to run this, where you're going to install it. So that would entail how much processing power that you would need.
Got it. Thank you.
Yeah.
So a Raspberry Pi is a pretty easy way to get started, it sounds like, and probably a lot of us have exposure to that.
Yeah, so because we have a lot of exposure on the languages that can run on the Pi. Of course, if you're a C developer or C++ developer, it might make sense to have a microcontroller running. Then ESP32 actually has a Wi-Fi connection already, so you can program the Wi-Fi here. And I did try that. And I was looking at how does it connect to the Wi-Fi. I'm surprised how many lines of code, C code, just to connect a device to a Wi-Fi. And you appreciate, you learn to appreciate the abstraction layer that came, that helped us just simplify a lot of these things, because it can get complex.
Right on. Well, thanks for that, Ron. And anybody else want to come off mute and ask a final question here? You can interrupt me if you do. I'm going to proceed. I'm going to thank Ron Dagdag for joining us and giving the talk from Fort Worth, Texas. I did capture some screenshots and various things, so you can see them in the photos in Meetup. And I did capture the demo QR code and the link. So if people are trying to track that down, you can find that in there.
Awesome.
So again, thanks very much, Ron. And for the rest of y'all, Ron's presentation will show up in youtube.com/Boston Azure, usually within a day. And again, you can find us on Twitter at Boston Azure. And we do not expect any more attempts at in-person events in 2022. We'll get back to you for 2023. We're still planning, but we have one more virtual event that we're toying with or trying to get set up, and that's for December. I think it's 6th, 7th, or 8th. But follow the usual spaces for updates on that. And to the new members here who joined us for the first time, welcome, and hope to see you back. Hope to see you all back. Everybody have a good, safe evening, and see you another time.
Awesome.
Over and out.
Thanks
again, Ron.
Thanks, everyone.
Thanks, Ron.